Okay, so our next question is highest common factor HCF and lowest common multiple LCM. And these concepts are the most recurring concepts that have been told to us since our school time, right? But personally, I used to have some problem with it. Whenever I used to solve problems related to it, I was not able to, calculate proper HCF, LCM and all those things. But later on, I studied why exactly the concept is there, then how to calculate HCF and LCM. I watched random videos, YouTube videos, and finally at the conclusion I was able to solve the problems. Okay, I was able to grasp the concept. Okay, and today I'm going to share that knowledge with you. So let's get the basics first. I will delete this title here, and what I will do, let's take an example of 12 and 18, and I have written the factors of 12 and 18 here. Okay, so as you can see, there are factors of 12 and 18. So 1 is the factor of 12, then 2, then 3, then 4, then 6 and 12. And in many problems I have discussed about this. Okay, now let's talk about 18. The factors will be 1, 2, 3, 6, 9, 18. So basically the concept of HCF is to find the highest common factor. So these are the factors and we need to find highest common factors among them. So what we can do, let's find the common ones first. So let's say we have written some common ones, and as you can see 1 and 1 are common, so we will write this. Then we will have 2, then we will have 3, after that 4 is not there, 6 and 6 are common, and we don't have any other number. So the list will be completed, and as you can see the highest common factor is 6. So at conclusion, highest common factor of 12 and 18 is 6. Okay, now what about LCM? So LCM is basically lowest common multiples. So let's say let's write the multiples of it. Basically we are writing table of 12. Okay, in layman terms. So 12 will come first, then we will have 12 2s are 24, then 12 3s are 36, 12 4s are 48, 12 5s are 60, 12 6s are 72, and this will be enough. Then we will write 18. So 18 2s are 36, 18 3s are 54, 18 4s are 72, 18 5s are 90, and the series will go on. Okay, now we need to find lowest common multiple. So let's find common multiples first. So let's say C equal to, that is common will be 12 is not there, 24 is not there, 36 is 36 is there. Okay, so it will start from 36, then we will have 48, no 48 is not there, 60, and we will have 72. Okay, so 72 is there, and the series will continue. Okay, now the lowest common multiple is 36. So LCM of 12 and 18 is 36. I hope the concept is clear, guys. Now let's take this concept even more further. Let's discuss more about how we can directly calculate HCF in layman terms. Now let's talk about 12 here. So we have 12 number, and what we can do, we can start from 2. So these are the basic multiples of that is basic factors of the 12. Okay, we will start from 2, then we will have 2 into 6, that is 2 6 are 12. Now we will break down this 6. So the 6 will be broken down into 2 into 3. Now there is no possibility that we can break these numbers. So ultimately what will happen, so 2 into 2 is 2 square. So always write in the highest power of the number, right, according to the situation that is there. So 12 is basically 2 square into 3. Then let's talk about 18 here. So 18 will be equal to 2 into 9 2s are 18. So 2 into 9 is 18. Then we will break down this 9. So 2 into 9 is basically 3 into 3, because it will not be divided by 2. Then we will have to increase the number. So 3 into 3. So it will eventually become 2 square. Not 2 square. 2 into 3 square. It will become 2 into 3 square. And this is 18. Now let's focus on these numbers. This is 12 equal to 2 square into 3, and 18 is equal to 2 into 3 square. See, now focus on these numbers, guys. 12 and 18. Now we have this 2 square into 3 and 2 into 3 square. So what we will going to do to calculate the HCF, that is highest common factor, we will consider the lowest power of both the common numbers. Okay, so common numbers here is 2 and the lowest value of a power is 1 here. So 2 to the power 1 is there. So what we will do, we will do 2 to the power 1 into what is lower between 3 and 2. Sorry, not 3 to the power and 3 to the power 2 is 3 to the power 1. So we will take the least value, 3 to the power 1. So basically 2 into 3 is 6. So HCF will be 6. Now let's see how we can solve the LCM problem. So we will consider the same numbers 12 and 18. Right now what we can do, we will have to take the maximum number. Okay, so we have 2 square into 3 and here 2 into 3 square, right? Now we will have to take the highest power of each common number I'm talking about. So LCM will be equal to 2 square, that is the highest power is 2 here, and 3 square, so highest power is 2. Okay, so 2 square is 4 and 3 square is 3 3s are 9. So 9 4s are 36. Okay, so 36 is the LCM of this 12 and 18. I hope you understood the proper logic. See, when we try to solve the HCF and LCM using the normal programming, what we can do, we can eventually have to calculate, let's say, HCF of 12 and 18. What we can eventually do is to get all the factors of it. Okay, get all factors of 12 and 18. After that, what we will do, we will check all the common factors that are there and we will pick the highest common factor between them. Okay, this is as simple as that. So the step one will be calculate all factors of 12 and 18. Okay, then step 2 will be getting the common factors, select the highest one. Okay, now for LCM, let's say to calculate LCM of 12 and 18, we will eventually have a list of multiples of 12 and 18. Let's say up to 10 numbers we have stored a list. So 12 and 24 and 36, up to 10 numbers we are storing it, and then we are storing it 18 into 36, 18 into 236. Then we have 18, 36, 54 and 72. And this will go up to 10 numbers, and we will eventually calculate the common factors, and then we will select the lowest common multiple. This is as simple as that, but it is more time consuming. This is more like a brute force solution. So what we can do, we can optimize more time, and there is a concept that there is an algorithm using the Euclidean's algorithm. So Euclidean's algorithm is there to use the long division method to calculate the HCF, and eventually after we can calculate the LCM, and by the special formula that we have, and we will talk about that special formula. Okay guys, now let's see how to find the GCD or HCF of two numbers using the long division method, that is Euclidean's algorithm. Okay, now we are interested in calculating the HCF of, let's say, two numbers, and we are taking 12 and 18 here in our case for the sample purpose. Now there are some terms that you need to understand, and I will paste it right here. So let's keep this aside. So basically the thing which is being divided, the number which is being divided is called a dividend. Then the number which is dividing is the divisor. The number here 1 is the quotient, and the number remaining, that is 6 here, is remainder. Okay, now these are the terms that you need to understand. Okay, cool. Now what we will do, the long division method is basically dividing the numbers, two numbers, until the remainder gets 0. So what will happen, let's keep this 18 as dividend first, okay, and this 12 as divisor, and we will see why we are, we can also take 12 as the dividend and 18 as the divisor, doesn't matter, it will come to this original position. So let's keep this bigger number as dividend and the lower number as divisor, and 12, let's do the normal division process. So 12 ones are 12, and the remaining number will be 6. Cool. Now what will happen next time, we will use this remainder as the newly divisor. Okay, we will use the newly created remainder as the current divisor. Now the current divisor is 12, and the current divisor that we have will become the dividend. So what will happen, basically we will divide this 12 by 6. So the current divisor that we had will become the new dividend, okay. Now the newly formed remainder will become the new divisor. Now what will happen, we will do similar division. So 6 2s are 12. Now the remainder gets 0. When my remainder is 0, the divisor is my HCF. Keep this thing in mind, that when my remainder is 0, the HCF is basically my current divisor. Now are you guys noticing something? This thing is being repeated several times until some base condition is executed. These calculations are being executed, and until some condition is met, that is until the remainder gets 0. Are you guys noticing something? This is what the recursion concept is, and we can use the recursion concept to approach this and solve the problem. So let's see how we can solve it. We will write a function that is HCF, which will take two variables, a and b. Now a here, let's say a here is the dividend, okay, and b here is the divisor. So when you call this function at any point of time, let's say you have called the function, right, HCF of the dividend. What was the dividend here? 18 was the dividend, and what was the divisor? 12 was the divisor. So this is how you will call the function. A base condition will appear, and as I told you, in every recursion related problems, a base condition will always be there. And what we will do at last, we will return something. So what is something? Okay, what's happening here? Every time what's happening, a reminder is getting created, a reminder we are getting every time, okay, and that reminder becomes a new divisor, and the current divisor becomes the new dividend, okay. Every time what's happening, every time the new reminder that we have becomes the new divisor, and the current divisor that we have becomes the new dividend. So let's call this function again. Now a is my dividend. So what is my new dividend here? So my current divisor is the new dividend. So we will pass, this was our current divisor, we will pass b as it is, because it is my current dividend, and the value basically 18 by 12. So basically my a% b, that is remainder a% b, when you divide the dividend by the divisor, you will get a remainder, and that remainder will be my new divisor, okay. And it is as simple as that. Now what will be the base condition? As I told you, whenever my remainder is 0, my current divisor is my answer. So what we can write, if my current remainder is equal to 0, we can directly return the divisor. So here my divisor is b, so we will return b. So this is what the function looks like. We can optimize it again. So instead of calculating the a% b again, see, we can move this or execute these steps further, and let's say what will happen if we follow the same rule, same pattern. So what happens, the current remainder that I have becomes the current divisor, and the current divisor that I have becomes the dividend, okay. So this will happen. So what I can conclude from it is that when my divisor gets 0, my current dividend is my HCF. So instead of writing this, what we can write, basically my divisor gets 0. If my divisor gets 0, we can return the dividend, okay. So this is how you can optimize it. Now what will happen, let's try to do the dry run here, and let's call the function. So basically we are calling this function HCF of 18 and 12. So what will happen, according to our function, it will check, let me make it, so what will happen, it will check if my b So basically A is my dividend and B is the divisor. My divisor is 0 or not. So 12 is the condition will fail. So it will call again one function HCF of 18, that is the B will be passed to this. So 12 and A% B, that is 18% 12 is 6. Okay, now it will check if my divisor is 0 or not. It is not 0. So it will call again some function with 6 and 12 modulo 6. So 12 modulo 6 is 0. Now what will happen, it will check if my divisor is 0 or not. My divisor is 0, so it will return 6. So 6 is my HCF or GCD, whatever you say. Okay, so this is how you calculate the HCF. Okay, now we have already discussed calculation of LCM using the brute force approach, but there is another formula available to us, that is GCD into LCM is equal to A into B. So basically A and B are any two numbers, and GCD of that number into LCM of those two numbers is equal to multiplication of those number. It is the formula that we have. Let's say we have 12 and 18 number, for example. We have calculated GCD. So what was GCD of 12 and 18? So 12 and 18, it was 6. Okay, so 6 into LCM is equal to A into B. Okay, so A into B is 12 into 18. Now let's do things. So LCM will be 12 into 18 by 6. So 6 2s are 12, 18 2s are 36. And I hope you remember this. So LCM of 12 and 18 was 36. So this is how you calculate the LCM. So let's say we have given two numbers, A equal to 12 and B equal to 18. Now we will find the GCD by directly calling the GCD function that we wrote earlier. Okay, or let's say GCD equal to HCF function. We have written HCF of A and B. Okay, so this is how you got the HCD, not HCD, GCD. Okay, now you will find LCM. So LCM will be equal to, you can directly print LCM using A multiplied by B, you can have the brackets here, divided by the GCD. Okay, GCD. So this is how you get the LCM. Whew. This was a lot, but I hope you understood the concepts. So thanks for watching. Let's try to incorporate this into actual code. Okay, now let's code the HCF and LCM problem. Here I'm not going to tell you the brute force approach, because it is like more tedious, because we need to find factors of both the numbers, and then we'll need to check by applying a loop, that is which number is the biggest, right? That is more tedious work, and it is simple as well. Okay, now here we will going to see the recursive approach. So here I have created a function HCF, and as I told you in the or as I explained you in the explanation part, that is every time when the divisor is getting divided, okay, the new dividend will be replaced as a new divisor. Okay, so here we are dealing with the same thing. We'll return HCF of B comma A% B. So this is what the next divisor. So divisor becomes the next dividend. Okay, that's what we are doing here. And if B is equal to 0, then we will return A. That is the final value. Okay, here I have declared two variables, int A comma B, and I am taking both the numbers as an input from the user, and I'm just calling the function. So GCD equal to HCF of A comma B, right? So HCF of A comma B is GCD, and as we know that LCM is what? So there is a formula, that is A into B, that is multiplication of both the numbers, is equal to multiplication of GCD into LCM, right? So that's why if you want to calculate LCM, you can have a multiplication of both the numbers, and you can divide that number by the GCD. Okay, so here I have written C out the LCM of A and B is A% B, A multiplied by B divided by GCD. Okay, now let's say if you want to give the input 16 and 32, if you try to run it, you will get HCF as 16, because the highest common factor is that is highest common I would say divisor is the 16, and the LCM is 32. Okay, so if you try to give something like 4 and 12, so the factor should be 4 and the LCM should be 12. It's your time to do the code. Thanks for watching.